Hello everyone, welcome to Geometry, Chapter 11, Section 3, Volume. So we're going to start off with just some volume formulas. So the volume of a sphere, V for volume, capital V, is equal to 4 pi r cubed over 3, where r is once again the radius. Bottom left here, cone, volume is equal to pi r squared h over 3, where r is once again the radius, and h is the height. It has to be perpendicular to the bottom here, as we can see in this picture to the left. Prism, remember we had the right prisms, rectangular prisms and right prisms. So for rectangular prisms and right prisms, going to be V for volume equals base times height. So the area of the base and the area and the height of the prism. And then for a pyramid, this will be regular pyramids. The V volume is going to be equal to BH over 3, where B is the area of the base, and H is the height of the pyramid. So start off with some rectangular prisms working through these. So once again, volume is equal to the area of the base times the height. A good way to think about it though is the length times the width times the height. Length times width times height. So it could also be LWH. So for example 1, you don't have to really worry about which one of these is the base if you just use the length, width, and height one. So for example, you could just say, well, 5 times 7 times 4, in any order at all, ends up being 140. And then for our label, it's cubic centimeters. Okay, so for normal area and surface area, we used square centimeters, square units, whatever kind. In volume, we're going to use cubic units. And the reason why is just like with area, when you had like 5 centimeters times 7 centimeters, we said centimeters, centimeters, that's how we get square centimeters, kind of like x times x is x squared. For when you have 3 of them though, just like if you would add an additional x on there, you would have an additional centimeter here, which gets you cubed instead of squared. On number 2, the volume of this rectangular prism. Once again, length times width times height, they're all the same. So you do 6 times 6 times 6, or 6 cubed, and so our volume ends up being 216 cubic feet. We don't say cubed feet, but we say cubic feet. Continuing on, so there's just a right prism now in general, not necessarily a rectangular prism, but a right prism in general, not the oblique ones where they're slanted. Formula, like we said earlier, is the area of the base times the height. And so we have to figure out what is the base on each of these. So remember, the base is going to be the two sides, the two faces of this shape that are congruent to each other. So in this case, on this right prism, the bases are going to be the top and bottom triangle. So the area of one base, so you have to remember, okay, well, how do you find the area of a triangle? Well, it's 1/2 the base of the triangle times the height. And thankfully we know 7 and 10 to be the base and the height either way, for either number, for either base or the height, doesn't matter which one's which, since they're both perpendicular to each other. So that means the area of the base ends up being 1/2 times 7 times 10 in either order. So the area of the base of this prism ends up being 35 square whatever units, because it's area. So now we know for our formula we need area of the base times the height. We know the base to be 35. We know the height to be 5, distance between the two bases. So we plug this one in. And we say, okay, well, volume is equal to 35 times 5. And so we end up getting the volume of this prism to be 175. And we don't know our units. So what I'm going to have us write, just to get into a habit of knowing what units we have, is to make sure it's cubic units. So we'll put units rather than like centimeters or meters or feet, because we don't know what it is. All right, Next, I'm going to work on some cones. So a cone has one base that is a circle, and then meets at a common vertex. So the formula for volume of a cone is going to be pi r squared h over 3. Now, if you think about it for a moment, the pi r squared is the area of the base, is the area of a circle. So similar to the prism, we're taking the area of the base times the height, but rather now we're dividing by 3, whereas before we just had the area of the base times the height. So in order to know the volume of this cone in example 3, we need to know the radius. We have the formula first, pi r squared h over 3. And the two things we need to know are the radius and the height. Well, we're given the radius to be 12 from the center to the edge of the circle, and we're given the height to be 5. So now we have enough information to plug this one in and solve from there. So volume is equal to pi times 12 squared times 5 over 3. So in terms of pi, to not round it yet, if you multiply 12 squared and 5 together, so 144 and 5, you get 720 pi over 3. That reduces to 240 pi. Now, if you want the approximate nearest tenth or whatever you call it, let's go nearest whole number this time actually, 754. And for both of these, we'll just say cubic units, because we do not know the units, so we'll leave it as cubic units. Example 4, the volume of this cone. Once again, we know we need to know the radius and the height. The radius this time is going to be 2. We know that because the whole diameter is 4, and the radius is half of that. And the height is 4. So we plug this one in and we solve. So volume is equal to pi times 2 squared times 4, all divided by 3. So in terms of pi, if we simplify that, we end up getting volume to be 16 over 3, aka 5 1/3, or 5.3 repeating, pi cubic centimeters. Or to the nearest tenth, would be approximately 16.8 cubic centimeters, depending on what you're asked for. Example 5, you're given the volume of a cone, and we're told it's 405 pi cubic inches. And you're told it has a diameter of 18, and we're asked to find the height. Well, let's first write down the formula. So volume is equal to pi r squared height over 3. This time we know the volume to be 405 pi cubic inches. We know the radius is 9 inches. We know that because the diameter is 18. Whoopsie. Diameter is 18. And the radius is going to be half of that. What we don't know and we want to find is the height. So what we do is we plug in what we know and solve for what we don't. 405 pi goes where volume goes. Pi goes where pi goes. 9 goes where the radius goes. And height goes where height goes, because we don't know it yet. And we start solving. So a good first step is to multiply by 3. And to square the 9. So if we multiply by 3, we end up getting 1,215 pi. And on the left side, on the right side, they reduce. And you're left with 81 from 9 squared, pi times height. Now if we divide both sides by 81 pi, we'll be left with our height. Gives us a height of exactly 15 inches. Now there could have been a few different ways you went about solving that problem once it was set up. And let's say you didn't want to multiply by 3 right away like I did, and you wanted to square the 9 right away. Well, you could and just call that 81. Then from there, if you wanted to, with the pi 81h over 3, you could have reduced the 81 and 3 to 27 pi times height, and then divided by 27 pi on each side. If that doesn't make sense to you, that's okay. Just ignore that I said it. And if it does make sense to you and you like that method or even did that method already, great. We're going to skip example 6 because we're actually not going to be learning the volume of a cylinder. Meaning, we're on to example 7, the last page of these notes. So a pyramid. We're going to do one problem for a pyramid, 2 problems for a sphere. We're done with the notes. So a pyramid has one base that's a polygon, and then the other sides all meet at a common vertex in their triangles. So the formula for volume of a pyramid, reminder from earlier this lesson, is the area of the base times the height over 3. It's very similar actually to the volume of a cone, where we did pi r squared h over 3, because pi r squared was the area of the base as well. So we have to just know which one the base is. We have to figure that out. So in this case, the base is going to be this triangle here on the bottom. So the volume is the area of the base times the height over 3. So we need the area of the base and we need the height. Well, we know the height has to run perpendicular to the base up to the top of the figure at the common vertex. And so it's going to be this dashed line coming down that we're told is 3. The area of the base, remember area of a triangle for the base is 1/2 times the base of the triangle times the height of the triangle. Two sides that are perpendicular to each other. It's going to be 3 and 4. So we're going to do 1/2, 3 times 4, which results in 6. So we have 6 as the area of the base. So we plug the 6 and the 3 in. And we get volume is equal to 6 times 3 divided by 3. So you end up getting the volume of this pyramid to be 6 cubic units. Last but not least, we have the formula for a sphere. So a sphere, the volume is 4 pi r cubed over 3. That's a unique formula, 4 pi r cubed over 3. Example 8, find the radius of a sphere with a volume of 7,776 pi cubic feet. So the only variable we need to find the volume is the radius. So the only variable we need to find the radius is the volume, which we're given. So we plug in volume, 7,776 pi equals 4 pi r cubed over 3. And I'm going to start out by multiplying by 3 over 4 pi. By 3 over 4 pi. Now you might choose to go about this differently. Maybe it doesn't make sense to you to do that right away, to do that all in one step. And if that doesn't make sense to do that to you all in one step, that's perfectly fine. If it makes way more sense to you to just multiply by 3 in the first step, you definitely can. What you would do after this step is you would get whatever result you have there, pi, equals 4 pi r cubed. And then from there you would divide by 4 pi and continue on. I'm actually just going to combine that into one step when I divide or multiply by 3 over 4 pi. So what's going to happen is not only am I multiplying by 3 in this step on both sides, I'm also dividing by 4 pi in the same step. So the pi's are going to reduce on the left and the right. On the right, the 4's and the 3's also reduce. So on the right side, we're just going to be left with r cubed. On the left side, we need to take 3 over 4 times 7,776. And if we do that, we get 5,832. So now we have 5,832 is equal to r cubed. Well, similar to how we solved when something was equal to r squared, we square rooted it. Well, to undo a cube, rather than square root, we're going to what's called cubic root. And so you do the same symbol, except for there's a little 3 in there now. A little 3 on the left side and kind of that little hook there on the left of the radical. And so the cubic root, aka what times itself 3 times, is what we're going to be finding. So a quick little side example over here is that the cubic root of 27, for example, is 3, because 3 times 3 times 3 is 27. Another good example would be that the cubic root over here of 64 would be 4, because 4 times 4 times 4 is 64. So on a much bigger scale, the cubic root of 5,832 will be 18 feet. And that gives us our radius, because a cubic root and cube undo each other, just like a square and square root do. Last but not least, example 9. Find the volume of a sphere if the surface area is 196 pi, and we're told to leave our answer just in terms of pi. Alright, so throwback, we have to start with surface area. Now, reminder for the volume, though, we need 4 pi r cubed over 3, meaning we need the radius to find the volume. So what we have to do is take our surface area formula. Surface area is equal to 4 pi r squared. And we have to plug the surface area in to solve for the radius. And then we'll get the radius and plug it in to our volume formula and solve. So that's big picture what's going on. So we are told the surface area is 196 pi. So we plug that in and start solving. So I'm going to divide by 4 pi on both sides. The pi's reduce. And 196 divided by 4 is 49. So 49 equals r squared. And like we talked about a moment ago, we'll square root to undo the square. And the radius is 7. So now we take this radius and we're going to plug it in to the volume formula. So volume is equal to 4 pi 7 cubed over 3. So if we take 7 cubed, that'll be 343. If we take 343 times 4 on the top, we get 1,372 pi over 3 cubic units. If you wanted to leave it as a decimal, you could. You would just have 0.3 repeating, not just 0.3, because we're not told to round. We're told to leave it in terms of pi, which means they want it to be an exact answer. All right, that is section 3 of chapter 11, doing volume of three-dimensional